Oh, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hanif and a very good evening to our beloved lecturer, Sir Shuhairini. So for today video presentation, I'm going to give a presentation about the benefit of having ACARS in aviation industries. So we're going to the next slide, which is the history and background. So ACARS is also known as Aircraft Communication Addressing and Reporting System. The protocol was designed by Airing and introduced in 1978. This one is a digital data link system for transmission of short messages between aircraft and ground stations via airband radio or satellite. The protocol was designed by Airing and deployed in 1978, as I mentioned before. Using the telex format, more ACARS radio stations were added subsequently by SITA. In an effort to reduce crew workload and improve data integrity, the engineering department at Airing introduced the ACARS system in July 1978 as essentially an automated time clock system. Teledyne launch customer. Teledyne controls produced the avionics and the launch customer was Vietnam Airlines. The original expansion of the abbreviation was Airing Communication Addressing and Reporting System. So the next slide is about the current issues. The first major downside seen with the ACARS platform is the fact that errors cannot be automatically corrected should an internal fault occur. The pilot, co-pilot, and other relevant personnel are notified. They will then need to correct the problem by using manual methods or system-wide troubleshooting. During fluid situations that may represent an in-flight emergency, such as lack of automatic correction, may adversely affect the ability to recover from an incident. It should be expected another issue with the ACARS system is its relative antiquity when compared to modern avionics package. Even though enhanced omnibus specifications have been adopted, the fact of the matter is that a massive amount of onboard cabling needs to be installed for the architecture to operate correctly. This can be a challenge, not only in terms of basic maintenance issues, but such as connection will dramatically affect the weight of an aircraft. Designers and manufacturers have had to consider this parameter, and it is not uncommon for technicians to be forced to work around such cabling. While there is no doubt that there are indeed some drawbacks associated with this framework, it needs to be mentioned that ACARS system is still one of the most reliable trusted avionics packages currently in existence. So for the next slide is about the future and analytical. So for the first point is the aircraft communication addressing and reporting system will not disappear in 2035 or 2030 for that matter. This is because IPS is a new network infrastructure under development by the SAE International Airing Industry Activities IPS Subcommittee. It is based on Internet Protocol, which is known as IP, using commercial off-the-shelf, as known as COTS, products to support air-to-ground aeronautical safety services communication, whereas ACARS is aviation specific. IPS will use multiple line of sight and beyond line of sight subnetworks that operates in protected spectrum allocated by the International Telecommunication Union, which is known as ITU, and ICAO for safety services, including Inmarsat, Swift Broadband, Iridium Certus, Aeromax, Future Satcom, and L-band digital aeronautical communication system. This is effectively the multi-link ACARS concept described by SITA, the industry's other ACARS service provider. For the next slide, which is benefits. So ACARS interface with flight management system, which is known as FMS, acting as a communication system for flight plans and weather information to be sent from the ground to the FMS. This enables the airline to update FMS while in flight and allows the flight crew to evaluate new weather condition or alternative flight plans. ACARS is also used to send information from the aircraft to ground station about the condition of various aircraft systems. ACARS is used to send information from the aircraft to ground station about the condition of various aircraft systems and sensors in real time. Maintenance fault and abnormal events are also transmitted to ground stations along with detailed messages, which are used by the airline for monitoring equipment health and to better plan repair and maintenance activities. So for the next point, a major function of ACARS is to automatically detect and report the start of each major flight phase, called OOI events, in the industry, which is known as out of the gate, off the ground, on the ground, and into the gate. These events are detected using input from aircraft sensors mounted on doors, parking brakes, and struts. At the start of each flight phase, an ACARS message is transmitted to the ground describing that flight phase, the time at which it occurred, and other related information such as the amount of fuel on board or the flight origin and destination. These messages are used to track the status of aircraft and crews. At the same time, this new generation aircraft generate up to 4 times the amount of aircraft communication addressing and reporting system data than their predecessors, leading to cost and congestion increases that reduce the overall operational gain. In response, airlines are now looking for new ways to improve throughput and reduce this cost by sending particular messages over different media. ACARS over IP, which is known as AOIP, is the newest option for the communication. AOIP harnesses the advantage of ACARS while also utilizing the growing availability and decreasing costs of broadband cellular connectivity on the ground and IP capability, SATCOM connectivity when airborne. The specific mechanism vary by aircraft and the type of system used, but in general, standard ACARS, which is known as ARINC 618 messages, are encapsulated in IP messages between the aircraft and ground-based messages handlers for processing. AOIP provides the ability to offload the growing volume of airlines operation communication, which is known as AOC, ACARS information from VHF, HF, and narrowband safety. Services SATCOM to broadband connectivity, engine, and aircraft ACARS data has grown 25% to almost 75% between new and older generation of aircraft. Sending this data over ACARS over IP will help alleviate network congestion and manage cost efficiencies. Dispatch critical or air traffic services. ACARS will continue to be sent over VHF and narrowband safety services SATCOM.